Hello, how are we all doing? Tonight we're going to be going over multiplying and dividing radical expressions. So we're going to go through the few steps right here. We're going to do some examples together, and you're going to know what to do before you even know what hit you. So, when you are multiplying or dividing radicals, the very first thing you want to do is either multiply or divide the coefficients. So these numbers out in front here are the coefficients, 8 and 1/4, 4, and this would be a 1. We'll get to this one in a second. That one's a tricky one. Down here you have 48 and 12 and so on. So you want to multiply or divide the coefficients. After you do that, you want to multiply or divide the radicals. Multiply or divide the radicals. So what's under the radical sign here? So here would be a 5 and a 15, an x squared, and a 16x to the 4th. That one's a tricky one. This, again, kind of tricky. Down here, 54 and 3, and so on. And the last thing you want to do is, if possible, you want to simplify. Simplify whatever you end up with, making sure that you don't have any perfect square factors underneath the radical, or perfect cubes under this one in that case. So with those 3 steps, you should be able to finish every one of these problems. So we're going to start out with the first example right here. We want to start by multiplying or dividing the coefficients. This is a multiplication problem. So we want to multiply 8 times 1/4. Well, 8 times 1/4 gives us 2. And then we want to multiply together the 5 and the 15. So if we use our handy dandy calculator, 5 times 15 gives us a 75. So this would be 2 square root of 75. So we multiplied the coefficients, we multiplied the radicals. Now we want to see, can we simplify this? Well, 25 can be broken down, 75 can be broken down into, I gave it away there, 2 radical 25 radical 3, which is 2 times 5 radical 3, which is just 10 radical 3. Bing, bang, boom, there's your first answer. See, not so tough. Moving on to something a little trickier though, because they're not all going to be that easy. We got to throw some variables into the mix. So here we have a 4 out in front and a 1 out in front, invisible 1 there. Again, it's a multiplication problem, so we want to multiply the coefficients. 4 times 1 is just 4. And then we're going to have the cube root. Well, if we multiply these inside, you have a 16. This coefficient here is a 1. So 16 times 1 is 16. X squared times x to the 4th is actually x to the 6. You want to add those. The 2 plus 4 gives you a 6 there. So we have 4 cube root of 16 x to the 6th. Can we break that down at all? Well, we need to think of our cube roots now. So I know 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. So it looks like 8 right there is actually a perfect cube that goes into 16. So we're going to have our 4. 16 can be broken down into the cube root of 8 and the cube root of 2. And x to the 6th, well, it's divisible by 3, so that's actually a perfect cube also. So we have 4 cube root of 8x to the 6th, cube root of 2. So that's going to be 4 times cube root of 8 is 2, cube root of x to the 6 is x to the 2nd, cube root of 2. For our final answer there, 4 times 2 gives us an 8, x squared, cube root of 2. Okay, that one's a little trickier, I know, because it's got those variables in there, and you need to get really good at finding perfect squares and perfect cubes that are variables. You need to be looking at the exponents. Moving on to number 3, probably the trickiest one on the page here. This is a binomial times a binomial, so you're going to use your favorite 4-letter F word. That's right, FOIL. We want to do the firsts. So 4 times 4, that's a pretty easy one, is 16. We want to do the outers. 4 times negative square root of 6 is negative 4 square root of 6. We want to do the inners. which is positive 4 square root of 6. And we want to do the lasts. Positive square root of 6 times negative square root of 6. Let's just write that down for right now as it's going to be a negative, right? Because a negative times a positive. So negative radical 6 times positive radical 6. Those are our lasts. Okay, so we get our firsts, our outers, our inners, and our lasts. Well, this is multiplying and dividing, so let's look at this multiplying here. What is the square root of 6 times the square root of 6 going to be? Well, that will be the square root of 36. So we're going to have 16 minus 4 radical 6. And I know some of you already saw this, but let it go for a minute. Plus 4 radical 6 minus the square root of 36. And what I said there is some of you noticed that this negative 4 radical 6 and this positive 4 radical 6 are going to cancel out right now. So we'll have 16 minus radical 36. And those of you who are really good with your perfect squares knows that it goes 1, 4, 9, 16, 25, and 36 is a perfect square. The square root of 36 is 6. So that's 16 minus 6, which gives us a 10. So that whole complicated thing there turned out to just be equal to 10. Moving on to number 4. A little tricky just because it's a division problem, but that shouldn't scare you at all because you're just going to follow your steps here. Multiply or divide the coefficients. So 48 divided by 12. 48 divided by, 12, right? And then we're going to have radical 54 divided by radical 3. Okay, so 48 divided by 12 we know is 4. And there was this thing called the quotient rule, if you recall, that said you could take this piece here and turn it into a big radical sign, 54 divided by 3. So 54 divided by 3 in our handy-dandy calculator gives us 18. So 4 radical 18. 4 times the square root of 18. But you always need to do that last step there. We need to see if we can simplify that at all. 18, we know it can be broken down into a 9 and a 2. 9 is a perfect square, so we like that. Bring down our 4. So you have 4 times the square root of 9 is 3, times the square root of 2, which gives you a big old 12 square root of el deuce. Doing great so far. Two more to do. These ones look a little more complicated just because they're not written like a division problem, but that's the reason that I wrote this like this. It's just a fraction, okay? Fractions are division. We know out in front here we have a 1, right? So we have 1 cube root of 32x to the 4th over 2 cube root of x. We might have to go in a little bit of a different order here for this one because 1 divided by 2, well, that gives us 0.5, which isn't going to help much. And now we have the cube root of 32x to the 4th. So is there anything that goes into 32 that is a perfect cube? Well, our perfect cubes again are 1, 8, 27, then 64. So we're already past 32 now. 8 goes in there again. So this is the same thing as the cube root of 8, and then we're going to have the cube root of 4, because 8 times 4 gives us a 32. And now we need to break this x to the 4th up, because that's not a perfect cube. So we're going to have some in here, we're going to have some in here. We want the highest multiple of 3 that goes into 4. So that would just be 3. With a 1 left over, right? And then we want to have that all over 2 cube root of x. Now you ready for how crazy this is about to get here? If we simplify this out a little bit, the cube root of 8 is 2. The cube root of x to the 3rd is just x. And then here we still have the cube root of 4x over 2 cube root of x. So now we want to divide our coefficients. 2x divided by 2 gives us a 2. And now we want to divide the cube root of 4x divided by the cube root of x. So if you recall, just like we did up here, that's the same thing as one big cube root of 4x over x. And in that case, you know that the x's here can cancel, and you're left with just the cube root of 4, and it was on the top, so it stays on the top. This would all be over 1, but you don't have to write that if you don't want to. Let me slide that up there. Sorry you couldn't see the bottom. And this last example here, again, looks kind of challenging, but you don't need to be afraid. Fear not, we can do it. When you are dividing a polynomial by a monomial, you need to split it up so that this goes with both terms on the top. So we want to have 15 square root of 8 over 5 square root of 2 minus 5 square root of 6 over 5 square root of 2. All I did was take this and split it up into both pieces so that we can divide it. Now we're just going to follow our steps from the top up here. Multiply or divide the coefficients, multiply or divide the radicals, and then simplify. So, taking the first step, 15 divided by 5 is 3. Square root of 8 divided by square root of 2, well, we know that that's going to be the same thing as the square root of 8 over 2, which is just the square root of 4. Yes, I know some of you will be able to skip that step. Minus, dividing this out over here, 5 divided by 5 is a 1. Square root of 6 divided by square root of 2 is the same thing as the square root of 6 over 2, which is the square root of 3. So this will be the square root of 3. And now we know that the square root of 4 is 2, so this is 3 times 2 minus 1 radical 3, or 6 minus radical 3. You don't have to put that 1 in there if you don't want to. There is your answer. Sorry, I should have boxed this one over here too. And you are good. We will be doing some practice with this in class tomorrow. Some of them are a little tricky, especially the ones with the variables, but that's okay. We'll power through it, and I will see you tomorrow.